Hi, everybody. Welcome back to Constellation. I'm Sascha Segan from Qualcomm, and I'm really happy to have Zach Supalla, the CEO of Particle, here to talk about his business and what Particle does and the new Tachion, which is a project that I've been just interested in and kind of fascinated by for it feels like a year now, and it's finally coming to fruition, and people are getting it in their hands. They're doing things with them. And I'm just so excited to see what people are going to do with these devices. Zach, thanks so much for coming on our stream.
Absolutely. Thanks for having me.
Great. So just to start with the basic background, actually, before we talk about Particle as a whole, just because I'm so psyched for Tachion, give us the Tachion pitch.
Absolutely. So Tachion is a single board computer. It looks like this. So you can think about it in the world of like Raspberry Pi and little computers that you can use to build whatever you want. And this is a very powerful one. So it is a 5G connected AI enabled IoT single board computer. And so if we kind of go through that, it has a cellular connection, which means that you can plug this thing in, you can put it anywhere in the world and it'll just work and it'll connect. It has an AI accelerator, so it's using Qualcomm silicon under the hood and has the ability to run both just like big, heavy workloads. It's very powerful. And also it can run models. And so it can do all sorts of cool things with vision and audio and things out in the world. And it's kind of an all-in-one package where a developer has everything they need to build a solution, including a bunch of cloud services that we use to provide monitoring and controls and over-the-air software updates and everything that you need to deploy the software and to manage devices that are powered by this kind of tech out in the field.
And now you mentioned the cloud services, and when people go and look at Particle's website, cloud services seem to be most of what you're selling, right?
That's right.
Yeah. So why? So first of all, what are the cloud services that have been your specialty up until now, and why go into creating an SBC?
Totally. So I think the best way to think of Particle is we're an infrastructure company. And so I define infrastructure here broadly in that we provide technology for people who are building intelligent devices, which IoT, Edge Computing, Edge AI, they're sort of all versions of a widget that's out in the world that's supposed to be smart, right? And the challenge with building any kind of those devices is there's a lot of infrastructure. There's a lot of stuff under the hood that is, to borrow a term from Amazon Web Services, undifferentiated heavy lifting, right? It's like a lot of work, doesn't actually make your product better than the next guy's, but it's stuff you have to do. And so Particle's value proposition is we make it easier to build those kind of solutions by providing all of that infrastructure. And a lot of what we do is on the cloud, but also a lot of what we do is on the edge. Like we don't really, the thing that sets us apart is we're providing the entire tech stack. And the fact that some of that is software that's running on like the chip that's in here, and some of that is software that runs in the cloud is, all part of making it the solution work, right? It's across the entire spectrum of tech.
And so when you talk about supplying this tech stack, it's past management, right? We're also talking about deployment. We're also talking about providing a uniform way to program a lot of different kinds of devices, right?
That's right. So the sort of center of it is reprogrammability. So it's all about being able to deploy software applications and models to the device and to the cloud and get all that stuff working together. We also have a data pipeline to sort of pass data from the device to the cloud and sort of manage it as it goes and run scripts and response and store it and things like that. We do a lot of connectivity management. So once you get into the world of like cellular and 5G, it's like there's a lot of complexity there, and we want it to be that you don't have to be an expert in cellular networking to connect a thing to a cellular network. So we do a lot of the connectivity management stuff. And all that stuff is useful both for the first prototype, right? When you have one of these things, you need all these tools to like manage that thing if it's somewhere out in the world. And when you have 100,000 of them, you need the same tools. They look a little different because you start to think about doing stuff en masse rather than individually, but it's all the same infrastructure. And so we really think of ourselves as a prototype to production platform. We want to make it really easy for people to get started with the first prototype. We don't care whether you're intending to scale or not. Of course, we want to help you when you scale if you do, but like it's great tooling to get started. And also, if you then scale up to many, many devices, we got all the stuff that you need to be able to handle that at scale.
Now, the 5G element is one of the things that's really unique here.
Mm-hmm.
And I think a lot of people, when doing projects, don't really consider cellular because of the difficulty of managing the service provider component
That's right.
of the
Yeah.
situation. And
Mm-hmm.
so, what have you done to make that easier for makers?
Well, in some sense, I think that um, the user expectations are set by our smartphones, right? Like we all have a cellular device we carry it around in our pocket, and it just works. Like you don't have to think that hard about its cellular connection. Maybe you occasionally like turn on and off airplane mode to, like switch back and forth between networks. Although we've had to do less and less in that as we go along. Like the OS is getting better and better at handling that stuff. The problem when people then go build an IoT product is that none of that stuff is there. And so they have an expectation of some degree of like, oh, it just works. And cellular networks don't just work. There's a lot of tech happening to make your smartphone work that way. And so that's where people kind of hit a brick wall. And they're like, God, this is really complicated. And am I going to staff up a whole team of network engineers who have deep expertise in decades of cellular networking to do this? Like, people kind of bounce off of it and say, oh, I'll just connect to a Wi-Fi network. And so in some sense, I think what we do is we just reintroduce that simplicity. Like we have taken a lot of the same ideas of how things are supposed to work, which is like you plug it in and it connects, right? And there's a whole bunch of stuff that we did on like SIM provisioning and eSIM management and monitoring the connection and intelligently switching back and forth between different networks or between cellular and Wi-Fi. And like that's all under the hood and just kind of works. And so you get that like smartphone-like experience, and that means you can use that network and not have to sweat the details too much.
Yeah, and that's all stuff that I feel like is not in it's not in a lot of developers or makers builds or distros of Linux.
Right.
It's kind of one of the big it's one of the big things, if not the big thing that
Mhm.
AOSP added to the concept of Linux,
Totally.
which is all of this management of the cellular networking and all of this handling of the negotiation with the cellular provider. So, are these packages that people can install into whatever distro they choose? Is there a particular distro that you've built here? What's the integration of this into the operating system?
Yeah. So the way that we do it here in Tachyon, I mean, to your point, like Android is very well built for this because it was built for smartphones. When people are then building IoT products where it makes sense to use Android, basically anything with like a screen, Android's a really good fit, right? Like if you're making you're making like the Peloton, and the Peloton is like basically a screen that's duct taped to a
It's a tablet. It's
right.
just a
Like, I
tablet.
mean, I don't think the Peloton people would like it described that way, but like it is, right? It's a screen. Use Android. Great. Right. But when you're outside of the world of like, it's an app with a screen, then Android doesn't fit. And then you switch to Linux. And to your point, you don't have any of that stuff. And so the way that we built it for Tachyon, we have our own Linux distribution that has gone out with Tachyon. It's based on sort of Ubuntu and Debian under the hood. And so it'll be very familiar for anybody who's used either of those. And we've really put in everything necessary for the system to work out of the box. For instance, some of that is like modem management type stuff, but there's this higher level of like the onboarding process where you go through and you create an account and that SIM gets provisioned to your account. Like we're handling all of that stuff at the OS layer. And our intent is a lot of that stuff is available as a Linux package or a Debian package that you can apt-get install on another system as well. So we are going to be supporting a lot of these capabilities for any Linux-based system. Not everything is in there yet. And so right now it's like Tachyon has everything. And then over time, we'll sort of pull out the pieces we can into packages and deliver them on different systems and make sure that they work regardless of what piece of device you're using.
So is it that you want to deliver these packages across more available physical hardware products, or that you're trying to enable people who want to use different flavors of Linux on Tachyon?
Well, sort of both, right? And I think that in some sense, the way that we launched Tachyon was intentionally kind of a customer discovery vehicle. We did it as a pre-order campaign on Kickstarter. Particle started as a Kickstarter campaign 10 years ago. So in some sense, this was like a return to form. But we hadn't done one for a very long time because our business has gotten to be more predictable, I guess. Like we have gotten really good at supporting microcontroller-based products and things like that. It's been what we've been doing for 10 years. Tachyon was totally new. We were entering single-board computers and application processors and 5G and Edge AI, and we're like, okay, we think we know what people want here, but we're not gonna we're gonna take a exploratory approach and make a product that we think is really good, that has a lot of really valuable stuff in it. And we will discover from customers once they get it, what are the parts of that that they get the most value out of and whether they want to see more from us. And that will sort of drive our roadmap. So, how we think about what comes next with Tachyon and, what do we do with this stuff, right? Do we, are customers going to want to run other flavors of Linux? Are they going to want to run Yocto? Are they going to want to run Android or Windows? It technically can do all those things, right? That's sort of one direction of taking this platform and making it kind of work with all different kinds of software. And the other direction is taking the software that we built for it and then making it work with lots of different devices. And some of that might be our own, expanded portfolio of single board computers. And so right now we're sort of like, yes, all of those things are interesting. We will build a more concrete roadmap after people have played around with it for a little longer.
Yeah, I've been really curious about the Kickstarter thing too, because you see periodically there's two groups of, as there's two groups of people on Kickstarter. And there are the people who have a dream and don't have the money for the dream and are hoping to make the dream happen. And then there are these real companies like you, and I would say Unihertz in mobile is another one that does this a lot, who are real companies and don't necessarily need that crowdfunding money to make the product happen. Right. So what's the role of Kickstarter for a company where you're not necessarily dependent on crowdfunding money?
Yeah. Well, I'll actually break it into three. I think there's three different reasons why people would go on Kickstarter, and it's sort of always some combination of these things. One is actual funding, like I need dollars to put towards this thing. Two is marketing, right? Like I'm going to use this as a platform to just get eyeballs. And then three is discovery. Like I want to learn what people want, and I'm intentionally announcing a product before it's fully baked so that I can sort of incorporate that feedback. So when we first started, we needed all three of those things. We had no audience, we had no money, and we had no customers yet. So like, Kickstarter is perfect for, new companies developing a thing, right? I think then the question is, why do some people keep using it later on? And sometimes, for instance, Peak Design is a company that I love. They do great products. They launch everything they do on Kickstarter. I think it's just marketing. Yeah. I don't think they need the money. I don't think they need the discovery. They know what to build. They've been doing this a while. It's just a great marketing platform. For Tachyon, and the reason we came back to Kickstarter is, to your point, like we're not looking for dollars to apply to this. Like we generate revenue, we have investors, like we have sources of capital. And so we wanted both marketing and discovery, but very specifically because it's so different from everything we've done before. We're like, we need to learn because some of our intuitions about what this product should be are going to be wrong, and we really wanted feedback. And two, we do want to get out into a new audience because while there's a lot of overlap between developers who do microcontrollers and like Linux-based systems, those are also in some cases very different worlds. So, but I think with discovery, to give an example, we did surveys after we collected our first 1,000 backers. We sent out surveys during the campaign and asked, what are you going to do with this? And what are you looking for? What are the parts of it that you find interesting? I think something like 60% of people responded to the survey. And so for anybody who's ever done surveys of customers, that's ridiculous. Yeah. Like 5% would be good, right? So that's the kind of engagement that we've been able to get. And that's been where we've gotten the most value out of it.
Okay. So now you guys also, I feel like this is a very exciting month for you guys because the devices are finally, we got very lucky with the timing of the stream because the devices are finally making their way to the purchasers now, right?
Yep.
And so what are you seeing people start to do with it? And which of the aspects are they most heavily using? Is everybody using the 5G? Are applications using the NPU? What's what are you seeing start to develop?
Yeah. So I think the categories that we're seeing get the most, the deepest exploration, generally like cameras, robotics, and I don't know whether to define these as two different categories, like autonomy. And so maybe that's just sort of one big umbrella term. Let's start with cameras because it's a little cleaner, right?
Yeah.
Things whose function is based on having a camera pointed at something and then telling you what that thing is, right? So we've got kind of on the lower end, we've got object detection models that you can train to solve a particular problem. At the higher end, you've got visual language models and things like that. Like in general, one of the reasons we wanted to get into this space with Edge AI is we said a lot of problems that used to be solved with sensors can now be solved with cameras, and you can solve them better or cheaper or with something that's easier to install. And so there's a lot of need for sort of good tooling there. So that's one big area. We saw a lot of interest in cameras. And then there's sort of robotics, drones, autonomy. I'll make that one category where you have something where you want it to use a camera and sensors to understand its environment and then do something in that environment.
Right, take an action in the physical world.
Yeah, which we can sort of broadly call robotics. It's a great robotics dev kit, right? Because it has all those things. And so I think where we're seeing the most pull is where what people want is everything, right? They want the AI accelerator and the 5G connection and the fact that it's super low power and the fact that it's small and like it's the sum, it just checks every box, because those are the places where prior to Tachyon there just was not anything out there, right? You can assemble something, but you would have to like go get all these pieces and it gets real expensive and cumbersome very quickly. So that's where we're seeing the most immediate pull. But also, the feedback so far has been very positive, and my expectation is like we'll start to see more pull for just one of those when people realize, well, technically I could use something other than Tachyon, but it turns out people really like this Tachyon thing, so maybe it does a better job of doing the thing I could have done with a Raspberry Pi, right? Or could have done with
right. And the Raspberry Pi, and I was thinking about the 5G and the NPU because those are the things that the Raspberry Pi doesn't have. I mean, right. to get even I have a bunch of show and tells on my desk. To get even decent local Wi-Fi performance with this Raspberry Pi, I did this. And
it's quite an antenna there.
That is not something that you necessarily want to have to do.
Right.
Yeah.
I think that's where, this is a big part of why we picked a Qualcomm chip for this product, because I sort of think of IoT, Edge Computing, Edge AI, like my sort of thesis on the market is it's not a market. It's really every market, right? But the sort of
it's 200 markets in a trench coat. Yeah.
Yes, exactly. And the pattern that sort of underlies all of that is all this cool tech got built for a particular purpose, and now we have it available to use in other purposes. So like, let's repurpose it, right? And so you can look at that with original IoT just being like, we have computers and ubiquitous Wi-Fi connectivity, so let's start connecting shit in your house, right? And then I think Cellular had a version of that, and Bluetooth had a version with wearables, and then Edge Computing is like, these computers are getting pretty cheap now. We can put them in everything, and so that you get that version. And Edge AI, wow, these models are amazing, right? Like, what else can we do with them? So you just have generations of like, let's repurpose the tech, and often the challenge is repurposing it in a way that it's actually usable in that other environment, because what you need over here is not the same as what you need over here. We saw clearly Qualcomm has built like incredible, well-optimized processors for smartphones, right? And smartphones are things that need to be very powerful and very low power and very affordable, given a certain sort of level of power. And small, and like, so there's all these things that make them good for smartphones, or you're like, well, that would be good for a robot or a camera or something else. Like, I want all those same things. And so being able to take that kind of great, extremely well optimized technology and then bring it to another space, and make it available to that audience, that's a lot of what, it's sort of what we do, but that's also what just like all this stuff is in my mind.
Yeah, and that's kind of I mean I'm not going to plug our company on our own stream, but
That's my job.
exactly. But that is kind of the overall narrative for Qualcomm right now, how we're taking this idea of, well, we're very good at doing a lot of calculations on something with a very small power envelope.
Mm-hmm.
And where can that be used? Well, it could be used in earbuds. It could definitely be used in glasses. It could be used in cars. Cars have batteries. You don't want to use up the batteries. And so you get this basic idea of high performance computing with a lot of understanding of a small power envelope, and we get to proliferate them up and down the stack to different kinds of devices.
Totally.
Now, talking about robotics, one thing that's been something about language has been on my mind for the past day or two, which is I see companies trying on these phrases, physical AI or embodied AI versus robotics. What do you think about those phrases? Like, do you
I think we
use
love to
either
come
of
up
them?
with a lot of names for the same thing, right?
Yeah.
Is like even the term robot is sort of like, what exactly is a robot? One of our advisors who has been helping us out for a decade, he says robotics, that's just a name for things you haven't come up with a good name for. Like when it becomes when it has a purpose, it will stop being called a robot. It will just be called whatever that thing is, right? And I think that's kind of true for IoT. It's sort of like the miscellaneous bucket. And
yeah, I mean, it's the Internet of
likes
Things, the most generic word in the world. It's things,
and everybody hates the term, so they just keep coming up with new ones, right? Like at the end of the day, that's the like pattern. So I think physical AI, I get the sort of vision of what it's supposed to represent. I think that the sort of the problem, I think, with the term AI in terms of like using it too broadly is that like really we have machine learning and we have AI, and AI is a type of machine learning, but like not all machine learning is AI. Right. And so I think when we have LLMs that have passed the Turing test, where like you can really convince yourself that I'm actually talking to a real person, like that's definitely AI. I don't think anyone would sort of question that. But then when you take these models and you say, well, I need a much smaller version of this model in order to run it on this robot, and it's going to be much more narrow in purpose, or I'm going to build up, sort of machine learning model that's whose purpose is to detect a very specific thing. Like I'm supposed to count objects, right? I think the question is like, what is intelligent? Like, what is the threshold for intelligence, right? It just gets caught up in all this like buzzwordy stuff. I think the important thing is, can you solve a problem better because of this stuff than you could have solved it before, right? And the good products start with a problem and solve them in a novel way with new technology. Whereas I think often the like buzzy stuff that kind of never goes anywhere starts with the tech and never really gets to a problem and a solution.
Well, I think also with AI, we've all gotten like I feel like before the LLM tsunami hit, we were relatively we in the industry were relatively comfortable with what the idea of AI was. It was, it was models that used neural networks to make decisions that could not be made purely algorithmically. And they were across a wide range of things. And then these sort of charismatic megafauna started stomping across the savannah. And so I think for a lot of people now, when they think of AI, they only think of the elephants and rhinoceroses and not the fact that there's this entire like ecosystem of, I don't know, voles and little birds and important bugs, which would be the old non-generative AI models, which are a lot of what gets run not only on Tachyon, but on your other products, right?
Yeah, I totally agree. I think a lot of the I think that we're still maybe a silicon generation or two away from the being able to do the kinds of things that we've gotten used to as ChatGPT and friends on the cloud, on the edge. Right now, as a result, you get a lot of like near miss kind of semi disappointing experiences when people try to do that on smartphones or when they try to do it in these kind of devices, which is like, you know, GPT-2 wasn't that cool. It was GPT-3 when it got cool, right? Like we're sort of in that maybe uncanny valley. But if you're just doing machine learning models and you're not trying to push into the same thing, unbelievable stuff that you can do, right?
Or
I
gotta say, so just to give the local LLM some credit, if you hold their hand a little, if you're working against a ragged document, for instance,
right,
or
and you constrain the scope and you narrow what it's supposed to do.
Exactly. As opposed to just treating it as the way people treat these cloud-based systems, which is the everything machine.
Right. Totally.
Yeah.
And I think we will get there. Like we're and probably in a couple of years. Like I don't think we're very far from it. We saw that, you sort of have this moment of all the pieces come together on the cloud. Same thing's going to happen on the edge. But I think right now the goal for anybody building a product like this is how do I solve a problem really, really well? And do I run the workloads on the edge or do I run them on the cloud? I mean, we've seen this for a decade in IoT is like when I'm solving a problem, I need to have some compute on the device and I want to have compute in the cloud. And I can choose to solve any given problem in one of those two places. And if it's on the device, it's going to be more constrained in terms of memory and processing and things like that, but it's real time. And I don't have to worry about the fact that there's a wireless network in the middle that like may or may not be there at any given moment, right? And I don't have to pay for the bytes that go on the wire. If I solve it in the cloud, well, now I've got infinite computing power.
Right.
And I can solve any problem in the world, but I am connected with a wireless network that like, maybe that's a wet string, right? Like at any given moment in time. And so that choice of where you apply the logic and the intelligence, I think should be, in the best cases, is dynamic. Like there's not a right answer. It's like, run the system, do what works best. Maybe in some environments it runs here, in some other environments it runs here. That's the like architecture of these kinds of systems. And it's not about edge AI or cloud AI. It's about like solving problems with all of these tools that I have available to me, which are pretty impressive.
And I mean, another concern with relying too heavily on the cloud, as we saw this week, is that if you are working with a cloud provider who is not intensely customer focused, they can rug pull you at any moment. And just as we saw with OpenAI and this backlash against them retiring all of their older models for GPT-5 and a whole bunch of their customers saying, hey, wait, we weren't warned about this. We had all sorts of processes around these older models. Where on one side, if OpenAI was a little more customer focused in that way, they might not have made that mistake. But on another side, if these folks had a workflow that involved the edge, maybe they would not have gotten caught as flat-footed.
Yeah. Right. And that's where I think you have where you run it, and also how much control do you have over the thing that it is that you're running. And the answer isn't always to retain full control over everything, because otherwise you would staff way too many engineers onto a problem.
Right. Otherwise you have to do everything yourself.
Yeah, that's no fun. But like, figuring out what problems do you outsource, what problems do you keep, and how do you make sure that your thing works regardless. And there's a lot of stuff to get right there.
So we have a question coming in, which I think goes over to another interesting, bigger topic. And the question from YouTube is, they would love to know if you guys are going to work on a system on module counterpart. And that makes me think, what's your interaction with the module makers out there, with companies like Quectel? Is this, are you already working with them? Is this a, is this a future partnership in that area, not with any specific company, but like an expansion of the way you guys want to do business in general? Yeah, that sort of thing.
Yeah, absolutely. So, I mean, we have great relationships with the module manufacturers. You mentioned Quectel. We work very closely with them on a number of our products, Tachion included. When it comes to intent for a SOM, so this is an open question for us. It is, I'll put it bluntly, we do have a SOM on our roadmap. Although I think
you heard it here first.
Yeah, there's some flexibility around it in that the question we have is like, is what people want for us to provide a SOM or a compute module, right? Whatever we would call it, for these kinds of products, because it's a different class than we have this for our IoT modules. We have the dev kit and the module. We built this thing so it is robust enough that for many customers, the answer is just ship with it inside your product. Like there's nothing keeping somebody from deploying a Tachyon inside a thing. It meets all the certifications. It's extremely robust. Like great for that. So when it comes to a SOM, like the answer might be we build our own. The answer might be like we hand a customer off to buy that from, directly from a module partner. And especially because these are Linux-based systems, maybe the answer is there's a portfolio of options that you sort of will run the same software the same way from different folks, right? We're still trying to figure that part out, and we would love feedback on it from folks, right? Like, what are you looking for as you scale, and how do we provide the best path? We also have a broader roadmap. We think of Tachion as the first device in our like application processor or edge computing ecosystem. And so there's other stuff that we're working on, but again, like we have a roadmap. It's very loose right now because we want to collect more input from folks about what they want. Do you want it to be more powerful, or do you want it to be smaller? Do you want it to be cheaper, right? Like there's lots of directions we can take the roadmap from here.
You guys are compatible with some of the existing SBC peripheral and case ecosystems too, right?
Yep, that's right. So yeah, if you look at this thing, there's a bunch of like clever little design things that we did to make it compatible. So for instance, like exact same form factor as the Raspberry Pi. It's technically a tiny bit shorter, but so it'll fit in any Raspberry Pi enclosures. It's got the 40-pin connector, which
that 40-pin connector really kind of jumped out at me.
Right. Yeah. Very obviously it will attach to hats. I will add that we did a lot more testing than I think that most folks who do things that are compatible with Raspberry Pi, where it's like, oh, actually none of the voltages match. Like we did a lot of testing to make sure that it worked with as many hats as we can get our hands on. So it's very high sort of electrical compatibility there. And then like we needed a place to put the 5G antenna. Of course, there is no 5G antenna on a Raspberry Pi. Obviously, that thing is big, right? So the question is, how do you do that without taking up, without making it no longer fit? And so usually at the end of the Raspberry Pi, you have the big like Ethernet port and the USB.
Yeah, it's ports. The whole like port shroud.
Right. Yeah. So we just gave up on that and said that's our antenna space, and it has USB-C and with power delivery and HDMI over USB-C. So we basically said like, okay, we'll get all that stuff from here, and then we can use that space to do the antenna, which is also like a cool bit of tech, right? Like this is a fancy, I'm blanking on the acronym for this, but like laser. There were lasers involved and plasma, and so it's it's a cool antenna.
So is there a concern? When people are designing projects with this? I assume the antenna needs to be on the external face of whatever they're designing. Like it can't be buried within the chest of the robot, right?
So this is it depends on the materials that you're using, but like this, you can absolutely put this in a product and have it work. Now that assumes that like the it's plastic, or it's a plastic enclosure, or at least the part around the antenna is plastic. So, and you're not like burying it under a bunch of stuff. So basic, like, try to get it as close to the tower, line of sight kind of thing applies, but it is built for that. And so when folks need different antenna designs, like external antennas, things like that stuff we can help sort of work through. But we built it so that somebody doesn't have to worry about those problems, because 5G antennas are really complicated. And if the only people we could sell this to are people who understand how to manage 5G antennas, we would have a very small market. So the answer is like, don't stick it in metal. Don't don't put it under stuff if you can avoid it. And generally test it. Like if it works, then it works. From our experience, it works. It performs incredibly well.
So another question came in to the point of, to the point of the charismatic megafauna AI versus the larger ecosystem AI.
Mm-hmm.
Can you give a few distinct use cases and frameworks that
Mm-hmm.
run on the Tachion's AI accelerator?
Yeah. So the YOLO, for instance, like a lot of the computer vision stuff starts with YOLO. There's many variants of it.
Hmm.
It performs great. And this is very powerful. So you can do those kinds of models, which you could do on a much smaller processor, but you can get very high frame rates and handle high resolution, which can help with certain use cases. We are we'd like to get more like LLMs and VLM kind of things running on it. And I'll make this a shout out to the people who work on these kinds of models. The processor, the NPU, has sufficient TOPS to be able to do those things. If we're working with the smaller models, the constraint is RAM. And so these systems have 8 gigabytes of RAM. And right now we're sort of using silicon that is, built for smartphones that only has a certain amount of RAM available. So like, I'm sure future generations of Qualcomm silicon will have more RAM. But in the meantime, call out to the folks working on the models, like the less RAM required, the more we can sort of enable this stuff for lots of
So
folks.
you have 8 gigs of RAM. How much of it is taken up by the system software?
It depends on how you run it, right? If you're running, I don't know off the top of my head, but I'd say if you're running the desktop, it's going to take up a decent chunk. But you can turn off the desktop environment and just run it headless, and then I would imagine we're talking less than a gig. So there's plenty available for the model.
Yeah. There's plenty available, and like in the smartphone world, I'll tell you, there's so much in the smartphone world. There is so much work and so much kind of coalescing around these 3 to 3.2 billion parameter models.
Yep.
Which often have really good performance, and there are a lot of open ones. We have a bunch of them on the AI Hub.
Mm-hmm.
And then we were showing earlier this year, 1 billion language models running on glasses. And those take less than a gig of RAM.
Right.
And so there is a lot of possibility for language as these 1 to 3 billion models get better and better.
Yeah, absolutely.
Another question from Discord. They're saying, what is the easiest way to implement AI models on this hardware? For instance, is Qualcomm AI Hub integration the way to go? Are there other frameworks that you've used or you've suggested or that you have code examples for? What's the easiest way to quickly get a model running on the system?
Yeah, so there's a couple of platforms that can work out of the box. One is Qualcomm AI Hub. So if you're looking to sort of get something up and running, that's a great part of the onboarding experience. You can get AI Hub models running from day one. Second is what a company that is now a part of Qualcomm, but was not when we started working on this, which is Edge Impulse. And so we have Edge Impulse model support as well. So like they have their own YOLO variant called YOLO Pro that's better designed for professional use cases. So we've gotten YOLO Pro up and running on Tachion. And then in general, it supports, because it's a Debian-based system, right? Really anything that you could run in a Linux-based environment is gonna run on. And so it has Python, right? Which means basically the entire universe of tools that is that requires using PyTorch or TensorFlow or things like that. Like it's all gonna be easy to tap into and pull down.
Yeah, I guess some people are, and like we see this a lot on Discord. Some people are like, well, it's really easy to implement things if you want to just be running on the CPU.
Mm-hmm.
But you have to be a little more attentive or a little more mindful if you're trying to get GPU and NPU into the conversation.
Right. And that's where it's been helpful to, have a working relationship with Qualcomm, because that's, that is where kind of where the rubber meets the road in terms of getting accelerated, optimized output. And of course, that's where there's also, there's work that can fall to the user or that we can do on like quantizing and optimizing model performance. And so that's a good place where if you have feedback of specific models that you want to run that don't perform as well as you'd want to out of the box, we can work with Qualcomm AI Hub and
I also
others
feel
to,
like this is what
optimize.
Qualcomm AI Hub does. Like this is
Yes.
what like they should be doing. And now that you guys are in the ecosystem, we all work together, and
Right.
we all should work together to make this optimized. How
Right.
many of these are out in the world now?
I think we've now shipped about 2,500 of them. So we had a big push. The first alpha units went out a couple months ago. We got like 10, and so we got our first feedback then. Then we did a beta run of 250, maybe a month or 6 weeks ago, and then about 2 weeks ago we shipped out the rest. And so at this point, most should be in people's hands. I mean, there's places where it takes a little bit longer to get shipped, but everything shipped out in July. And so we've had a lot of unboxings show up on the internet, and people, like, oh, here it is. And I appreciate it. It's been 10 years since we did a Kickstarter campaign. So I'm going to videotape the unboxing of this product was not quite as prolific then as it is now. So I've seen a lot of unboxings that make me very happy.
Oh, that's great. That's great. So, okay. So how do you get to be one of the first 10 alpha testers of a product? I know on our Discord, there's a lot of people who are like, I've heard a couple of people are being selected for such and such. How did you pick those people?
So what, when we were doing the alpha, first thing was we got 10. It was constrained by literally the number that we had available to us. We made a certain number, and then we gave out most of them to our engineering team for engineering work. And then we're like, okay, we got 10 left. So how do we use these 10? Let's get some alpha users. And so we went to the backers and said, like, if you're interested in volunteering, we're taking volunteers, and we will probably sort of constrain that by skill set and capabilities and things once we get the volunteer list. But volunteer if you're interested. So we got 50 people who signed up and said they'd be interested. And we basically said, okay, here's what we want. We want people who are actually willing to dedicate time to it. And so they will open the box, they will turn it on, they will go through the onboarding flow. And if we have particular things we want to test, like a great example is cellular connectivity. We can only test that in so many places because our employees are only in so many places. And so without paying people to go out and drive, which gets real expensive real fast, it's like, well, we'll just ship them to more people and ask them if it's working, right? So you needed to volunteer to do the work. And then we asked people to explain their background to see are there particular, we wanted a certain level of technical skill set because the out-of-box experience was not great yet. And we said, it's not, you have to be pretty technical to use the product at this point and do all this testing. So everybody who we accepted was quite technical. And in some cases, we're actually members of the Linux community. One of the volunteers was the person who runs the Modem Manager project, open source project in the Linux ecosystem, which is that's the thing. If you use cellular modems in Linux systems, it's running on Modem Manager. And so we're scrolling through the Google spreadsheet of people who filled out the form. And it's like, oh, the guy who runs Modem Manager.
And you're like, you need that.
He should get one.
He wants it. You need it. This is a match made in heaven.
Yeah, exactly. That's the great thing about open source is you never really know who does what, right? It's all nameless, faceless until you actually get into the community and you're like, oh yeah, there's actually a small number of people who make all this stuff work, and
a small number of people who are doing a large amount of unpaid labor.
Yes, exactly. And that interacts with inside Qualcomm and inside Canonical and inside these sort of organizations that do a lot of the heavier lifting, right? There ends up being a couple people who participate in that ecosystem and that that are really driving a lot of the work.
Your story actually makes me think of, so I obviously use a Snapdragon X Elite laptop, and I got access to one of our early Snapdragon X Elite reference devices, the red laptops. They were very, very red. And part of that deal was, as you say, the developers kept on setting essentially challenges for us with the early proto laptops. I remember one of them was you have to watch Netflix for 5 hours on the laptop this week. And I was like, I'm being paid to watch Netflix for work. Okay. Because they were debugging. At the time, they were debugging, I think, the Netflix DRM interaction, maybe with the video drivers, and they needed a lot of telemetry.
Mm-hmm.
And so, yeah, and so I guess a big part of being an alpha and beta tester is that you need to understand that the device is mostly yours, but still a little bit the developers.
Right.
Yeah.
Well, yeah, we had a great set of volunteers, and we, one of the deals that they got was they got the alpha unit, and then they got a real unit. Because we also didn't know it was an alpha unit, so it's like, this might be as good as the final one, but like, we're not going to punish you for accepting an early unit. And I think now we can look back and say the alpha units are pretty good. So they are slightly different, but mostly that just means you got two.
So we've been talking a lot about the cellular black magic, and cellular is definitely black magic. I've been doing cellular for about 25 years now, and it has never stopped being black magic. Did you have to make decisions in terms of regions, in terms of band support, in terms of carrier support? Were there things that you were optimizing for particular regions or locations when it came to dealing with your first cellular product, really?
Yeah. It's a great question. So this is definitely something that has gotten more complicated over time because the sort of band specificity of different countries. You say 5G and everybody's like, oh yeah, I got 5G. My country's got 5G. Well, different bands in different places. And that list of like the like matching bands to countries is and then carriers also is a very complicated three-dimensional
SA or NSA.
Right?
That's a whole nother axis you can go on.
That was a big, like one of our requirements was we wanted SA support. And that when we were getting cellular connectivity partners, that carved out a huge portion of folks that we were talking to. There's a couple of things that we focused on. We did want to make something that just works. That's always our goal.
Right.
Reality sometimes creates barriers against that. So we have two SKUs, which I think this is always, I'm looking forward to the day where we launch a cellular product and it's just one global SKU. Practically speaking, it like
almost, I will tell you, almost every cellular device manufacturer for almost all of time has had to have multiple global SKUs.
Right. Such a pain in the ass, but it is what it is. So we have two SKUs. And so depending on what country you're in, you pick one or the other. And then, so that sort of is a very high level band support. And so at that point, it becomes more of a SIM profile matching question, because in order for it to function in any country, what you need is the radio has to support the band has to be available in that country, and there has to be a carrier that is supported with that SIM profile that matches that band, because often you'll have different carriers in a certain country running on different bands. So you got to get like all the pieces to work. So the part that is least built out of those right now is the carrier list. And
that's always how it is.
And that is purposeful because it has an eSIM. So basically, on the Tachion, there is an embedded SIM that is EUICC SGP. This is where I get my numbers wrong. SGP 22 compliant, and I think will be SGP 32 compliant, which basically means it has loaded on. We can load SIM profiles onto it, and so we have a certain list. That list is getting longer as we speak. We keep adding to it, and the list of countries that it works out of the box is shorter than we'd like right now, but we keep adding more. And so two cool things that are cool about that. One is people who buy one can put on their own SIM profile. So it is not locked to our profiles. People can use their own. So if we haven't added support for the carrier yet, by the time you get around to it, you can do it on your own. And then we are going to be expanding the list of profiles that are available to customers so that over time, there are more and more things that will work out of the box without user intervention.
Great. Now we have another question in from Discord. I think this is interesting because you were talking about quantizing AI models and how to fit things into relatively low memory. A question from Discord says it's someone who's been experimenting with 1.58-bit quantization. Which is really, really tiny. And they're saying that it runs remarkably well on entry-level smartphone. Is there, I'm going to expand their question a little bit and say, is there a potential use for this extremely small quantization going down to 2-bit or 1.5-bit quantization when most of the chatter in the world is around 4-bit at least?
Right. So I think that the sort of give a very high level response, and then I sort of like where I see things going from here, if that makes sense. Right now, the silicon that is being released to deploy on the Edge AI, and this goes for the chipset that's in this as well, is essentially repurposed existing silicon, because the silicon tape out cycles are longer than people have had strong Edge AI strategies, right? So like, it's sort of like, what did I have that I could reuse, right? And so when we talk about this thing being a smartphone in a box, it really is. Like, this is silicon that was built for smartphones. And so as a result, I think there's a lot of optimization that comes into like, well, it has a lot of the things that I need to run models, but it was built prior to running models being the primary use case. And so we do a lot of optimization and work to try to get it to like perform well. But the next generation of silicon is going to be processors that were actually built specifically for running models. And so I think some of the there's a lot you can do in sort of quantization and optimization that like is applicable in the current generation that will hopefully become less important in the future as the silicon that's released on this stuff, starts to be the generation that was built specifically for this purpose.
So the silicon will become more powerful, and you aren't going to need these extreme optimization kludges, essentially.
Yeah, and not just more powerful, but like more similar to the environments that we deploy in the cloud, right? Because that's, I think, where a lot of the quantization optimization work is like taking a thing that was really built primarily for deployment in the cloud of a particular architecture, and then reprocessing it to work in a different architecture, right? And so regarding like specific optimization profiles, that's above my head personally, and I think others at Particle are deeper experts in it. But also that's where we partner with folks like Qualcomm AI Hub that are really
and I completely get what you're saying, and I totally agree that the point is the silicon is only going to get better from here on out, and so it's going to be able to handle more complex models from here on out. And so the idea of, are we going to have to crunch these models smaller and smaller and smaller? Not necessarily.
Right. And I think the question ended with, I was wondering if this is a potential future for computer vision use cases. So like, I'm very bullish on visual language models and their applicability for computer vision, because if I look right now at the computer vision world, you've got the like out of box YOLO models, which typically use the COCO data set, which is really good if what you're trying to do is detect people and cars. But if you're trying to detect things that aren't that, like, yes, it has a lot of images of other types, but often they're not useful. Like, I don't need apples usually, right? Like, that's not, the use cases for detecting apples are limited. And so as a result, people need to train their own models to do computer vision typically. And that puts it front loads a lot of work. It's not just that it's hard, it's that it means that you have to do a bunch of work before you can test whether your product has legs, right? I really think we get value in backloading work behind proving product market fit, right? So visual language models are great because you can say, well, tell me what you see, right? And like, and all of a sudden a bunch of stuff can be done with less front loaded work. The problem is, the magical visual language model that can understand everything it sees ever is going to be a real big model. And so the, one solution to that is quantization. But I think that the stuff that I'm very intrigued with is more sort of like branching of models and like focusing on narrower subsets. Like, if you want a model that's going to be a traffic camera and is going to do a good job of understanding what happens in the zone of a traffic camera, like a visual language model would be great if refined down to the set of ideas and concepts that are relevant to a traffic camera, right? It doesn't need to know what, like, fine art looks like. It's never going to see fine art.
Yeah.
Right?
And at Mobile World Congress, we were talking a lot about this, about how specialized models were really the potential future of the edge. We're running low on time, so I want to ask the one more question from Discord, and then let people find out where they can find out more and how they can get this. Are you interested in making one without 5G, or is 5G at the heart of this product?
Great question. And I think, like, when I talk about the fuzzy roadmap, right? The fuzzy roadmap does include, like variants without 5G, in that like maybe that's the thing we should do, and we're looking for feedback on it for sure. I think like the early users are people who want kind of everything, and so this is where often like we would love feedback from folks who say Tachyon looks great, except I'm not going to use it because X, right? Like, and if that because X is like, well, I don't need that thing. Great, we'd love to hear. We'd love to hear from you. That feedback would be very helpful. Zach@particle.io, just shoot me an email. But I think that in general, I'll tell you where we have sort of strong beliefs and weak beliefs. Is like strong belief is integrated connectivity and compute is the way. Meaning like, I don't think people want a really powerful edge computing system that never talks back to the cloud, right? Because a lot of the value ends up being like, well, let's check to make sure if it's doing the right job, and then like iterate, right? And you can't do any of that if it's offline. So we believe in that integration. We believe that there's a lot of untapped opportunity in 5G and cellular because, as we said it earlier, it's hard, and when it's hard, people don't use it. And if we make it easier, then people can use it. But we also, on the IoT side, we have Wi-Fi, we have cellular, we have multi-radio, we have LoRaWAN, like we have a portfolio. And so I expect that this side of the house will expand similarly into supporting a wider range of systems so that you can pick the processor that is the right fit for your thing, and then we can just handle all the sort of software and management of that system.
Great. Well, thank you so much for coming on. Where can people get the device, and where should they follow you on?
Yeah. Store.particle.io is our e-commerce store. So we have it available for them. We're spinning up distribution as well, but we don't have that all set up yet. So come buy one directly from us for the time being. If you want more information on how it works, developer.particle.io is the developer platform we set up for Tachyon. You can also see docs.particle.io, which is mostly our microcontroller stuff. And then community.particle.io is our forums where you can come chat with us and hang out with us. If you want to follow me individually, I think these days I tend to speak most on LinkedIn. And so username Z Supalla on LinkedIn. My email is zach@particle.io. I'm accessible. So if you have any feedback or questions on the product, or you're interested in either Tachyon or some other flavor that may exist in the future, shoot me an email.
Great. Well, thank you so much for coming on, Zach. And thank you all for watching and listening to the second episode of Constellation. We'll be back next month with a rundown of the things that we at Qualcomm are going to announce at Snapdragon Summit. And we promise that they will be impressive. I can't wait to see what people build with Tachyon. And yeah, have a great one.
Take care.